cloud this time and see how that goes. I guess I'm recording. And let's see, I think in Learning Suite, do I have Learning Suite here? I don't know, it sounds pretty interesting though. Presentation on variables. Okay, so today I got a fundamental concept in programming is this idea of a variable. So we're talking about variables and about constants. Did I say share? I'm going to say present. So today's mostly about variables and constants. Let's see if the thing works. That's great. Okay, this is your computer. It's not really your computer, but it's a picture of a computer. There is one place in the physical hardware of your computer, of this computer, where I can store a value, let it ferment, let it age for a while, let it sit there, and then later pull that value back. Here's some number that I need to remember, or some name I need to remember for later. There's one place I can put that in the physical hardware of the computer that I can pull it back, well, that I can readily pull it back. I guess there's a few places. But what am I talking about? What's the name for that part of your computer? Yeah, RAM. You can put a value onto your hard disk, but that's pretty distant in terms of being able to work with it. I've got to read it into RAM before I can have the processor work on it. And so yeah, it's like this. I don't know if you've ever seen memory. That's what it looks like. But that's what we're talking about. When we're dealing with this idea of variables, we're talking about how are we going to keep track of the information that we have stored in random access memory. So here's what a variable is. A variable is a location in memory. Do you know how much memory you have in your computer? Okay, so that's how much storage for your hard drive, a gigabyte. How much memory do you know? 8?
Yeah, RAM, right?
Yeah, RAM. Probably 8 gigabytes. Did you say gig? You said 8 gig earlier. Oh, I thought you said a gig. I thought, no one has just a gigabyte anymore these days. You said 8 gig, very good. Anyone have more? Pretty common to have 16. Anyone have 32? Yeah, I have 32 on my laptop, not my laptop, but on my desktop computer in my office, and there's a slot for another 32. I could have 64 gigabytes. It's kind of expensive, but I haven't ever actually used all 32 at the same time yet, so I'm not going to pay for it yet. So it's located. So we talk about that. How much storage are we talking about? Let me give you a feeling for how much, just exactly how much data you could put in memory. Anyone know how many bytes? So you're talking about 8 gigabytes of memory. How many bytes, or let's say how many megabytes, is the full text of the Book of Mormon? Do you know? It's about 1.5 megabytes. So, and a gigabyte is 1,000. Well, there's 1,024 megabytes. So you have 16,000, probably that's 1.5 times, so probably 12. You could put the full text of the Book of Mormon into your memory, just on your computer, more than 12,000 times. How tall is a stack of copies of the Book of Mormon? 12,000 high? Well, it's about 1 inch thick, so every 12 inches is a foot. It's 1,000 feet. You could stack up copies of the Book of Mormon, one on top of each other, 1,000 feet. Like you could stand on top of the Tanner building and you would still be looking up at the top of the stack, 1,000 feet up. How high are you up at the top of the Tanner building? You get about 10 feet per story, and we've got 7 stories, so you're on the 8th story. So 8 times 10, 80. How many times can you do it? 1,000. So you're 80, and you're looking up to the top of 1,000, even from the top of it. It's a lot. Okay, so you have a lot of memory in there. We need some way to be able to keep track of it all. We're going to put something in. Can you imagine? I don't know. Just put it in memory somewhere. I'll find it later. There's too much to look through just to find out where it is. You got to keep track of where it is. So that's what a variable is. A variable is it's a location in memory that has a name. That's the biggest part of it. But the name. So this is where a value of a particular data type can be stored and retrieved. This is what a variable is. So we've got this, some place in memory that we give a name to. And then we use that name to put a value there and to be able to pull it back. Okay. you probably know that everything in computers ultimately has to be stored as a series of ones and zeros, yeah? And so the smallest little chunk of memory that we will work with in VBA is a byte. It's 8 bits. So bit is the individual 1 or 0 on or off that we use to organize information. And so we will work in terms of bytes. A byte is just 8 bits. So this is, if I've got a byte of memory, I've got these 8 different locations where I can put a 1 or a 0. This is how I store the number 0. I just put 0 in all of those. This is how I store a 1. This is how I store a 2. Right? You've seen this? There's a 3, right? So we have, it's just binary notation. I have a 2's place, a 1's place. So this is I have 1, 2, I have 1, 1. I add those up and I've got 3. How much more do I have? That's what a 4 looks like. What's that? That's 65. Excellent. Okay, what's that? 255. How did you get to 255? You had to add up 128 plus 64 plus 32 plus 16 plus 8. You had to add all those up, and you did that so fast. How did you do it? Yeah. What's the next? Once I filled all of this up, if I have to go to the next level here, what would that be? Well, it would be twice what this is, 256. But I'm not quite there yet. I'm 1 less than that, and so it's just the next number minus 1, 255. Okay. So what is then the range? Let's go back here. What's the range that I could do with 1 byte of memory? In terms of number that I could store, what's my limit? The lowest I can store is 0. The highest I can store is 255, yeah. And there's just no more room. In fact, it turns out that if we have a data type, it's called byte. You know, we can make a variable of type byte. Let's just do that real quick. I don't even have Excel open. Let me open up Excel. A blank workbook. I'm going to come to my developer tab, go to Visual Basic, insert a module. I did that so fast. Developer tab, Visual Basic, and then insert module. The truth is, you probably don't need to do this along with me. It's enough to watch. But if you want to do it along, that's fine. So I'm going to make, before we recorded a macro, I'm just going to write one from scratch. Sub, I don't know, variable, demo. Dim x as a byte. X equals 255 debug.print x. So this should just declare a variable. This line right here is going to say to the interpreter, to the piece of software that runs my VBA, hey, I need some memory. The interpreter is going to go, great, I know what to do with memory. It's going to say, operating system, I need a byte of memory. Operating system is going to give back some memory, and the interpreter then is going to keep track of where that memory was, and it's going to know that we're going to call it x. I'll say x gets assigned the value 255, and I'll print that out. It should print out 255. View my immediate window, which is where I'll see this output. And I'm going to put this up at the top so you can see it better. I will run this, and there it is, 255. So if I'm thinking about this, this is what I've just done. I've just, somewhere in memory, I've put 8 ones right in a row. And they really are, right in a row next to each other. What would happen, I'll get you in a second, but what would happen if I tried to put one more 1 in there? What would happen? It is completely full. It would overflow. That's what happens when you try to put too much into something. It overflows. Watch this. I'm going to put 256. I'm going to run that. And the error is overflow. It overflowed. I got a bit now rolling around inside the computer. I don't know, it's just kind of shaking off the top. I don't know. So that's an error. I tried to put something into that variable that just doesn't fit, because when I made it, I said, listen, I only need 1 byte. That's the data type. There's a question over here.
When you're actually doing this in a practical application, is saving something, like putting the dimension as a byte versus like a string or a long, actually going to save memory in the coding run?
So the question is, you know, I could use a different type here. Instead of byte, I could use another data type called integer, which is the one we're about to talk about. Will it save memory? The answer is yes. Using byte instead of integer saves 1 byte. It turns out integer requires 2 bytes of RAM. That's what we're looking at right here. Requires 2 bytes of RAM. And so yeah, but how many bytes of RAM do you have? Billions and billions of them. Do you care if you save 1 or 2? No, you really don't. But I will show in this very class, not this very class meeting, but in this course, I will show you how to create thousands upon thousands of variables with one statement. And you may need to do that for one thing or another, depending on what kind of data you're manipulating. And once you're dealing with like maybe tens of thousands of variables, the difference between whether you're using 1 byte to allocate or 2 bytes can make a difference. So yeah. Okay. So what do you think? So it's twice as much memory, so I should be able to have twice the range, right? Right? No, way more than twice the range, because every time I add a new column, I double the capacity. And so if we can't have 9 bits. We don't work in sets of 9 bits. We work in sets of bytes. But if I had 9 bits, then I would have 0 through 256. I'm doubling my capacity just by adding that one more bit. And so, yeah, so, oh, I think I just gave away. But what am I showing right here? Yeah, that's 256. What's this? Were you looking ahead? How'd you do that so fast? Yeah, that's 1,000. I barely remembered that, but you're seeing ahead. That's fine. Okay, so we talked about the data type byte. I forget what that's showing, but the range is 0 to 255. Now, so what do you think the range is for integer? You might think 0 to 32,768. But it's not quite. It's a little bit more complex. Here's the integer type. But this brings up a question. What if we were talking only negative numbers, or only positive numbers, that would be right. But how are we going to deal with a negative value? So here's the way it actually works. And it's different in VBA than it is in many other languages. But here it says, listen, you're going to store a value somewhere here between, oh, it's not 32,000. It's 32,000, whatever 32,000 times 2 is. Because if I was to fill all these up with ones, it would be 64,000 something. So the idea is you're going to store some actual representation of a quantity here in memory, but then you're going to add it to some particular negative number. And so this all happens, you don't have to think about this. I just want you to understand how it actually happens. So here, if I've stored the number 100 in my 16 bits of memory, what number am I actually representing? This is what I've stored, but because this is the integer data type, it's not just the number that I've stored. It does a little bit of processing after that number. It says, all right, we start at negative 32,768. We add 1,000 onto it, and so that is representing negative 31,768. That's how that gets stored. So here is the number 32,767. That's how we would represent that. So what number are we actually storing? That's -1. So what would 0 look like? Yeah, a 1 in that top bit and everything else, and that is -3,768 plus that gives us 0. And I think this is that same 1,000 plus this number that gets us to 0, so that should be, yeah, that's actually 1,000. And so it's almost just like this sign. It tells us, hey, you know, is it a negative number or a positive number? This is one that would tell you. And you're never actually dealing with that bit. This is just what's happening in the background. So this is, yeah, so now I've got 32,768 plus, as big as I can actually record, 65,535. And that gets us to the maximum number. Now, for this class, I do expect you to know something about the integer data type. When it comes to the midterm exam, you won't need to know 32,767, but you will need to know roughly plus or minus 32,000. If I give you a number that's like 50,000, and I say, what data type could you use? And one of the choices is integer. Can you possibly mark integer? No, because it won't fit. If you tried to put that number into an integer variable, it would overflow. Yeah, and it would be an error. It wouldn't even run. Okay. So integer data type, there's your range, plus or minus 32,000 is what I'm expecting you to know. There's another data type called long integer. It's 4 bytes. Here's the range, plus or minus 2 billion. So, you know, if you're using integers, the nice thing about these integer types is they have all of that precision. Like every single one of those numbers you can represent in that range. How about decimals? Decimals a little bit different. So there's a couple of options. So here's one data type that we're leading up to. ultimately, everything has to be ones and zeros. So how do you get a decimal point in this? So for this data type, it says, listen, you just store an integer, some long integer, and then we'll know that it's always to 4 decimal points of precision. So here's a long number, count over 4 decimal points, that's where the decimal goes. We see how to store integers. Now this is how it stores decimals. This is one way. This is called a fixed point number. And so in this case, and dividing by 10,000 just moves the decimal place over. So if I only had 2 bytes, there is no fixed point number that is only 2 bytes. But if we had this, that's what it would be. Because we're saying, you know, we filled this all the way up, that's 65,000 divided by 10,000, and that number is 6.5. So I could do things to 4 decimal places of precision, but I can't go very large. So here's another one, 5.25. The data type that we're talking about is called currency. And the range is 922 billion, plus or minus 922 billion. Is that billion? That's hundreds, thousands, yeah, plus or minus 922 billion. And that's an 8-byte, it takes 8 bytes. You know, when you say, give me a variable of type currency, it immediately allocates 8 bytes of memory and says, this is for you to use, and it'll store that number there. Okay. Questions? Question here. Oh yeah, that really should be. So I'd edit this right now if I knew how to do that, but you're right. That should be positive. Thank you. Because negative 922 to negative 922 is not very much at all. It's a really small range. So at least we brought it right here. Okay. So here's a second option. So in that case, we just say, listen, we're always storing to 4 decimal points of precision. Another way is to say, well, you know what? We're always going to store an integer, but then we'll use a part of our memory to say, where does the decimal point go? The nice thing about the currency type, it doesn't take any memory to say where the decimal point goes. It always goes in the same place. But now we're saying, all right, we're going to say part of this memory is just telling us where the decimal goes. And so I've represented 3,574 here, you know, in this part that's not green. That's the integer. And because I'm saying no there are no digits of past the decimal, then that actually is 3574. But if I say there's 1 digit past the decimal, by putting a 1 there, that changes this to 357.4. If I say 2 decimal places, 3 decimal places, or 15, this must be 15 decimal places. Yeah, 1 less than 16. So 15 decimal places past. So with this approach, I can still be pretty big, or I can be really, really precise. But the point is, I've got a fixed number of digits to work with, and then the decimal place point. And this is called a floating point number. Have you heard that expression, floating point number? Yeah, that's where it comes from, is that because we say we got an integer, and then the point just goes where we tell it to go. So this is a floating point number. And there are 2 types of this. One is called single, and it's short for single precision floating point number. It takes 4 bytes, and your range is, that's huge. Look at that. That's what your range could be, but you're only precise to 7 significant digits. So you can make a really huge number, but you know, if you want to put like a 2 in here, you're out of luck. This one won't do it, because you're just saying how far. I've got 7 digits that I can actually store a value, and then I can push the decimal place a long way either direction. There's also one called double precision floating point number, and this one's really almost comical. Here's the range. You only have 15 digits of precision, but you know, finally we can do our. This is like we can finally do the national debt. Here we go. This is, you know, wait, we could probably do the national debt here. We do national debt? Yeah, we could have done the national debt here, not precisely, and that's what the range is here as well. Now, it turns out the actual implementation of this is a little bit more complicated than I've just said. Partition tells you where the decimal place is, but that gets us really, really close without going crazy about how this is actually implemented. How about a date? How do we represent dates? Ultimately, we got to get down to 1s and 0s. So what do? We just store the number of days before or after a particular date. That date happens to be December 30th, 1899. How do you pick December 30th, 1899 as a starting date? I don't know. I suspect it was actually a mistake. There actually is an error in the way that Excel, not VBA, but in the way that Excel deals with dates. And so there's something, I think they meant this to be January 1st, 1900, but that's the way it was actually implemented. So we've got 27,945 days plus that particular day. Anyone want to guess what day that is? Just guess based on the other things I've introduced to you in this class. You might have guessed it was the 4th of July somewhere in time, the bicentennial. So what was the question? 1976, is that 40 years ago? We're getting close, if it's not. Maybe it's more than 40 years. More than 40 years. So, yeah, right? So we have some initial date. We do some math to add on the number of days. Well, how are we going to do a date and a time? Well, it's just a fractional portion. So the number portion here gets us to the day, and then this part gets us to a particular part of the day, a particular portion of the day. So basically, date takes 8 bytes, and you have from, this is kind of, it's a little bit strange here, but the valid range is from midnight, January 1st, the year 100, up to December 31st, the year 9,999. What if you have to talk about a date that was before that? Can you imagine needing to deal with dates that are before this? Totally. I mean, if you're doing anything with archaeology and you're doing something like, 7 BC or something, that's way before this. Well, it's 107 years before this, 106 years. And so, but, date won't handle those kinds of dates. That's what your range is for dates. Am I going to expect you to know the range for dates for an exam? The answer is no. Don't spend time memorizing that. But understanding how dates work, a particular index date, and recording the number of days since then or before then is part of what I expect you to know in this class. How do we do a name? Again, we've got to get, how can we possibly do an A? Everything we've done so far has just been numeric. So in this case, we're going to say whatever character you want to represent, we're just going to assign a number to it. So here is, with 1 byte, I'm representing 65, and 65 happens to be capital A. So what is capital B? 66. Why isn't A 1? We'll talk about that in just a minute. So I'm just going to turn this representation on its side. So here's 1, A. So this set of 8 bits represents the 8. The next set represents the D. So it turns out that character number 100 is lowercase d. Character number 97 is lowercase a. The comma is 44. Space is 32. So each one of these symbols just has a number. We say, all right, we're going to store this information, figure out that number, put that number into memory, and then we have to remember when we read that memory, the interpreter has to know, oh, wait a minute, that says 65, but it knows this is a character. It has to know the data type tells it. Don't just look at it and say what number it is. You got to convert it into the character that it represents. And so that's what the ASCII table is for. It stands for American Standard Code for Information Exchange. I finally put that on a slide because I can never remember what it stood for. There it is. So this is just like the first half of the standard table. But we've got here 32 is a space, capital A is 65. What do we say? Lowercase d was 100, so we've seen some of these. These ones that are lower than 32, these are actually, they're called control characters. They're non-printable characters. And it goes back to you almost have to set the Wayback of computing for this to make a whole lot of sense here, the Wayback Machine. Because it's not just dealing with representing characters like in text files, but it's actually controlling hardware. So if I'm going to send, imagine that I'm going to transmit information across the wire. Have you ever seen like an old, like a movies that's set in the 1970s, 70s or 80s, and they're in a newsroom, and there's just this chatter going like crazy in the back of the newsroom. It sounds like people are typing like crazy. That's not people typing. Those are teletype machines. Those are like correspondents sending information into the newspaper from out in the field, and they're hooking up a device on one side of the telephone. The other side of the telephone is hooked up to literally to a printer. And it's actually, they're just pushing characters through the phone line and to print onto paper. Well, you have to have some way to tell it when have you got to the end of the line. And well, that's right here. Character number 13. You know, if I send character number 65, it types an A on the paper. If I send character number 13, it says, send the carriage back to start a new line. But if that's all I sent, it would just start typing right over the same characters that it just typed. So I also have to send it a character number 10, a line feed. I've got 2 separate characters. Send the print head back and advance the platen by 1 so it can start typing a new line. What if I wanted, and how many of you ever worked on a manual typewriter or electric typewriter? A few of you? What happens, you know, when you're like 5 characters from as wide as you can possibly go? What happens? You're typing along, type, 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 type. You're not paying attention to where it's going because you're reading something what you're typing, and then, yeah, the bell rings. Hey, you're almost to the end of the line. You know, and you, as a type operator, you've got to then, if it's manual, like push the platen back or hit the return button to move the print head back. But that little ding is actually in here as well. It's like number 7, audible bell, right? So if you send character number 7, it's supposed to say, that's the bell, ring the bell. That's what it means. And so the truth is, we don't do a whole lot with these characters here. Actually, one we do use a lot still is the horizontal tab. So if you ever worked with tab delimited data, the tab character actually is character number 9. It's just sitting in there. And you know, when your text editor opens it up, it goes, oh, here's a bunch of letters. I know how to do these letters. And then here's a 9. Oh, that's the tab. And it kind of tries to advance however the tab works. And that's how tab separated files work. It uses that tab character. It's just character number 9 in there. Okay. So one thing about the way we store strings, with all the numeric types we talked about, as soon as you say, I need a variable of this type, of single, it knows 4 bytes of data. You're going to need 4 bytes. And what if you need more than it can fit? You're out of luck. You told me to allocate 4 bytes. I allocated 4 bytes, and that's all you get. But characters now are different. Characters, we say, listen, this can be as long as you want. Like, what's the longest? The data type that we're going to see here in just a moment is called string, and it can be huge. You can put a whole book. A string can be up to 4 gigabytes in length. You know, you've got 16 gigabytes of RAM. You could take 1/4 of that RAM, and it would be a single string variable. That's a lot. And so we have to know, we have to have something that says how long is the string. Now, the thing to realize is that when we're talking about memory, you've got a bunch of 1s and 0s all right next to each other. This variable, it has to be contiguous. You got to have, a long run of these all right next to each other. And so what happens is we say, listen, we're going to start off with 4 bytes that are just going to tell us how long the string is. So whenever I say I'm going to have a string variable, immediately 4 bytes are gone because those 4 bytes tell me how long the string is. So if I'm storing this string, John, or Adams, space John, it takes 1 byte for each of these characters plus 4 bytes to tell me that it's 11 characters long. Is it 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So it's 11 characters long. And so here we have, in the first byte, we have a 1, a 2, an 8. Is that 11? Yeah, that's 11. And all the rest of these are zeros. And even though it looks like this is another 1s column, that's actually the 256 and the 512 and so forth. So this part just tells me how long the string is. And so I've got 1 character. So how much RAM does it take to store in a string John Adams? Adams, space John? Yeah, it's 4 bytes of overhead plus 1 for every character. So it takes 15 bytes. Is that a big deal? Not really. But I'd just like you to understand how this stuff works. So we have the data type string, and that is the range. 4 bytes plus 1 byte per character. Okay. So here we have some memory. First thing to realize is that your operating system is going to say, out of all the memory that we've got sitting around here in the computer, some of it's being used. Can you imagine what it would be like if you're running some program and the programs need to store some information and it uses the same piece of memory that some other program is storing information for? Imagine that this set of bytes right here, 2 programs are trying to refer to that set at the same time. And someone tries to put the number 65 there, and what used to be there was some string representation. They've just changed your string to put a capital A right in the middle of it if you have 2 different programs looking at the same piece of memory at the same time. So the operating system has to keep track of which programs it's allocated the memory to. So here I'm trying to represent that you've got some memory that's taken. Here's a block that's kind of engraved. That's used, it's not available. Here's some other that's used and not available. And at some point, we've got to say, all right, we need some more memory. Now, each one of these ones and zeros in memory, and how many of these ones and zeros do you have? Yeah. Oh, you're doing the math. Good. So how many gigabytes do you have? Okay, so you've got 8 gigabytes, and so you've got 8,000 bytes, but these are bits. So you've got 64,000 bits. You got a lot of them. And every single one of them has an address. That one has this address. So this is actually 2 different ways to look at the same address. So there's just, and they are numbered 0 through however much memory you've got. This is bit number 1. That's bit number 2. This is bit number 3. That is bit number, whatever that number is. It doesn't actually count sequentially with that. We're not starting at the very beginning of memory here. And then what we're seeing here is that same number represented in base 16. It's also called, what do we call base 16? Hexadecimal. Because it's a power of 2, it kind of works better for doing binary things than base 10 does. And so we typically think of memory addresses in hex base 16. But those are just 2 different ways. The one right next to it, it has another address. It's just the next one. If you're actually going to check this, it's actually just one more. Both of these numbers are just one more representation. And so when I give the statement dim x as integer, then the interpreter has to make the request to the operating system. I need some memory. By the way, do you know how much memory it asks for in this statement? How much memory are we asking for? I wouldn't expect you to memorize it. We talked about it today. It's 2 bytes, yeah. So the interpreter says to the operating system, I need 2 bytes of memory. Does the interpreter care where those are? I don't care where they are at all. I couldn't care less. Just give me 2. And the operating system says, great. Here's 8 bytes that are not being, 16 bits, so 2 bytes, that are not being used by anybody else right now. I'm going to allocate that to you, Microsoft Excel. No one else will be allowed to use it. And it will indicate back to the interpreter, here's the address of where that memory starts. The interpreter then knows, great, it starts at this particular bit, and I've got the next 16 bits to be able to work with. And so the interpreter is keeping track of this. When I say dim x as integer, the interpreter, when that line runs, it's going to go, great, I've got an address. I've got to keep track of the address. And so I'm showing the address here. It remembers the address, and it remembers that it's 2 bytes. So that next time when I say, give me whatever is in x, it goes, oh, great, I'm going to find that location in memory, and request whatever's there. The operating system will pass the information back, and we're actually looking for 2 bytes of it. How are we doing, folks? Questions? Okay, so far it's been pretty easy. Objects. Last time we got together, we talked about objects. Objects are, do you remember? Yeah, objects are a thing. Now, we talked about 2 characteristics of objects that are really important. One of them is objects have properties and objects have methods. So properties and methods. Someone tell me the difference between property and a method for an object. Or tell me what one of them is. Don't have to compare them. Compare and contrast. No, just what's one of those? Go ahead. So, right. Okay, so a method is something the object knows how to do. A property is something that tells me the way the object is. It's a characteristic of the object. And so if I think about a particular range, so here's range A2. I've listed 5 different properties of that object here. It has an object called address. That's telling me something about the way that object is. It has some of these properties you can change. Can we change the address of range A2? What do you think? Can we say range A2, you got a different address besides what's showing there? Tell me what your hope is. Your hope is yes? Your hope should be no. That when you say A2, it's really talking about A2 on the worksheet. That would be terrible. If you know what, A2 used to be A2, but I've now made it way over here in column 47 or something. That'd be really bad. Can I change the formula of a cell? Yeah. Can I change the value of a cell? Yeah. Can I change the column of a cell? No, it's going to stick there. So it's properties, sometimes you can change them, sometimes you can't change them. That's okay. But these are all things that describe the way this object is. And so every range object takes memory. It's like I've got 5 different variables here that are built into this object. That's exactly what these are. That is what properties are. They are variables that are part of an object. Now, methods, it turns out, methods don't actually get written into each one of the objects. So all of my range objects have exactly the same methods. And so we don't copy them into each one. We keep one copy of them separately. Okay, so that's what a property is. A property is just a variable that's a part of the object. So let's kind of take a look at this. This next part, we're going to do a little bit in Excel and a little bit with VBA in this. So we'll see that. But if so far, if you've been thinking, I totally got this, I'm going to check my email, it's time to finish that off and come back to me and bring your brains back to this. Because this part is one of the hardest parts about dealing with memory in VBA. And so we're going to spend the rest of our time, the rest of our meager 10 minutes, talking about this idea of an object variable. So the object is itself range A2. That is an object. But we can make variables that refer to objects. This is how we do it. Let's just go ahead and do this. I'm going to execute this. I'm going to go ahead and put this statement into Excel. Oops. So we've got that one. That's fine. I'll do another one here. Dim RNG as object. What I'm doing is I'm saying I am going to want this variable range to be able to refer to some location in memory. This range, I'm going to go put a value in A2 here. A2 has a value of, I'll put a formula. What did I say the formula was? 3 plus 5, 5 plus 3? Okay. So here now I've got range A2. It's got a formula, it's got a value, it's got a column, it's got an address, it's got all those properties. Because all those values are variables, then every one of these things has to be sitting somewhere in memory, right? There's actually a little variable out there somewhere in memory that's holding the address, that's holding the formula, it's holding the value, it's holding the row, it's holding the column. You might actually be inferring the row and the column without actually having to store them because some can be inferred from the other. But let's think about them as just being separate variables here. And so when I declare this, it says, just like when I declared that variable, it says, all right, operating system, I need some memory. And the operating system says, great, here's some memory. This memory now belongs to you. And it's going to be 8 bytes. It takes 8 bytes for this because what this variable is going to do is it is going to hold a reference. Here's how we do it. I am going to say set RNG equal to, and then some way to refer to that range A2. Now, I haven't told it which worksheet, so it'll assume the active worksheet. But what this does, it says, all right, go find out where this range A2 is. So somewhere in memory, if we can go back here, somewhere in all this memory, range A2 is sitting right here. And it's got a bunch of variables all right in a row that keep track of the information that it has. And so when I say set this variable equal to range A2, it says, great, tell me where is this thing located and store that memory address inside this variable. And so this variable now is, this variable is located at a location. I'm going to set range RNG equal to range A2. And now this variable is going to hold the memory address of where range A2 is. The key here is that it can be used to refer directly to the range. So in my code, I could change the formula. Watch this. I can say range A2 dot formula equals, and I'll put new formula in here, equals 10 times 10. And I'm going to show you the debugging tools here in just a minute. If you want to do this with me, press F8, and you'll just start to step through this code one line at a time. Doing all of this, so I execute that line. that we haven't used this variable yet, but it just says, okay, this is going to hold the address of whatever object I've referred to here. Now I'm going to change the formula that's in A2. I'll execute that line. I'm going to come back and look at A2. There it is, new formula in A2. But now here's the key. I can do something just like this. Maybe I'll make it 100 minus 1. But instead of saying range A2, have you guessed what's going to happen here? Range. This now, because I have bound this object variable onto a particular object, I can now use that as another way to refer to the object. This is one way to refer to the object. That finds that object. If it finds that location in memory where that object is stored, it changes the formula property from where that object is, and it sets it to here. I'll just drag my little yellow arrow back to this one. Let me split the screen. You can see that I still have 10 times 10 because I haven't executed this line yet. I'll press F8 to execute that line. And now it has changed that formula. So I could have multiple different object variables pointing at the same object. This is just another way to refer to a particular object. If you think about it, we've got billions of these ranges in here. Might be nice to remember where some of them are without having to refer to them by their whole long expression. Go ahead. Okay. Here's the question. So far, all these, we talked about variables, declaring variables by saying dim. It turns out that, and the question is, do you have to, couldn't we do this without saying dim range as object? Couldn't we skip this part? And the answer is yes, we could. But let me tell you what happens. There's one more data type I want to talk about. I don't have it in the slideshow. There's a data type called variant. When the folks wrote the language, the philosophy was, we want this language to be easy. Most computer programming languages are really, really picky. Like, you've got to have it exactly right. And if you don't have it right, what happens? You try to run it, you get an error. They just won't do it. When they're writing VBA, they said, when they're writing VB, actually, they said, we want this to be different. We want to let folks leave stuff out and to figure out what they meant. Doesn't that sound like a great idea? That's a really bad idea. I think that's a bad idea. But they thought, we want to try to figure out what you meant. And so if you don't declare the variable and just use it, then the VBA interpreter says, so I'm going to make this into a comment. I'm going to comment that line. And it's going to say that now the first time I'm going to see this symbol range is right here. The interpreter is going to get to this and it's going to go, RNG, what is that? It's no part of my language. It's not some function that was made somewhere. No one's declared a variable for this. It's not, a reserved word. It's not referring to some object. And it finally eliminates every other possibility, and it says, must be a variable. My poor programmer didn't declare the variable. And so it will declare it for us. What type is it going to make it? Integer, string? What do you think? It's going to make it this type variant. It would be the same as variant. Variant is an evil, evil data type that should only be used when absolutely necessary. It has, how much overhead is involved with a string? 4 bytes. How much overhead involved with variant? 22. 22 bytes of overhead. And the thing is, you treat it like an integer, it behaves like an integer. You treat it like a string, it behaves like, you treat it like an object, it behaves like an object. And so if I don't declare it, the interpreter will just, in the background, declare it for me as type variant, and it will still work. It's using a lot of excess memory, but that's not the big problem. The big problem with variant is that a whole bunch of assumptions now are going to be made about how that should behave, and those assumptions are not what you think they are. Okay, we only ever talked about variables. There's other stuff to talk about today, and so maybe we'll spend a little time talking about constants and operators next time we get together. Thanks for coming. I will see you in class Wednesday. Class dismissed.